Okay. Hi, everyone. Thank you for coming. Thank you, Flink Forward, for inviting me here. I'm really excited to be in Berlin and to meet all of you fine people. This is the subject of my talk. I hope you find it interesting, and I'm going to try to leave plenty of time for questions. And if you like this stuff and want to talk more about it, please find me a little bit later, or reach out to me over the Apache email system. So I'm at a company called People Pattern. We're a startup in Austin, Texas, and we do marketing software. I'm going to, in this presentation, take you through the work that we do, our product, and the way that we use Apache projects, including Apache Flink. So you always have to start a pitch with a problem, and the problem is basically that data silos make it difficult for marketers to do their job. And they just, in general, make life more difficult for a lot of us. So it's challenging to get a composite picture of a person or organization. The data about them resides in a lot of systems. A lot of them are walled gardens. Unfortunately, for anyone who's worked in data integration or trying to build data warehouses, you know that data often is not preserved or transmitted with any sort of regularity across systems. Essentially, you have to do integration work all the time. And even beyond that, the API protocols that house a lot of the data in enterprise systems and web scale systems, they all have different APIs. So you have different data and different APIs in order to get a data that underneath is really more or less the same sorts of data and is quite useful if you can harmonize it. So People Pattern's product tries to consolidate social data and analytics into a single platform based on open standards. We also have a data science team with specializations in natural language processing that allow us to enrich portraits with demographic and psychographic attributes that may not be stated explicitly, right? And the point is to help our users discover and segment potential customers. So we have use cases that range from lead generation to content marketing to activation on social channels. So starting with how do we actually do this? Well, the problem I was just describing is well known, and there's a community that came together in 2011 to put together a spec called activity streams. And you can think of this, if you're not familiar, as basically a public specification for describing digital activities and identities, but in a normalized format that would allow data that came from multiple online streams in order to be essentially merged together and allow you to use them as one. So these will typically take the form of an actor is doing something to an object or did at a certain time, or potentially an actor gave an object to a target, like a user put another user in a list. And nearly anything that you're going to see in your activity feeds from different channels kind of take some variant of this form. So part of that is describing an enumeration of different types of objects like person, organization, web page, that leave aside the specific name that any one channel might have for that and just try to get at the core of what it is. And then different types of activities like post or share or like that are more or less generic and used across the board. So this community came together, they wrote a spec, and then they waited, and several of the large players tried to do some stuff with activity streams, but unfortunately, Take One didn't have a great deal of success. So Activity Streams 2.0 is currently going through the W3C Social Web Working Group, and they're trying to do a number of things. So they're trying to simplify the vocabulary, take a lot of the stuff out of the spec that wasn't really all that widely used, expand the ontology to cover more types of objects and activities, and make it more extensible so that you can use Dublin Core metadata or other sorts of RDF standards directly in the spec. Schema.org is another that has a lot of popularity with the search engines and with people running web pages. So Activity Streams 2 using JSON LD and is able to bind to the RDF standard that's been around a long time and that's part of the way that people build web pages already. and allow for these other specifications outside of activity streams to be used directly in line with the activities that we trade. So it would be really great if activity streams becomes a W3C standard. We could see more momentum build towards widespread adoption. And it would also be great to see the companies who are custodians of personal data working together to make it more interoperable. As it's more interoperable, I believe it's more valuable. Unfortunately, the flip side of interoperability is portability. So if it's too easy for you to take your data out of a system that you've put it into, more people will take it out and move it around, and the balance of power shifts more towards the customer. I think in a lot of cases that's not the outcome that some of the big players want. So we're not seeing a ton of demonstrated commitment to open standards from social networks lately, unfortunately. So my crazy dream is that data should be interoperable by default, right? Instead of having hundreds of APIs that are all different and hundreds of data shapes that are all different, if communities that are working with data can come together and create some standards like activity streams for different problem domains, and players can over time realize the benefit of publishing and consuming data in common forms, that a lot of us will not need to do all of the data integration work, writing code ourselves, trying to make it scale, and copying data from place to place to place to place in different formats. So my theory, and I would love to have more people join in this mission, is what if we just decided to write and support code to make it easier to move data between each of the proprietary APIs and formats back to a public standard that has the momentum of the internet behind it, like activity streams. And actually, as I said, there may not be a lot of support from engineering at some of the big data players, but the good news is that doesn't really matter. So as long as APIs do exist that allow data to be taken in and out of those platforms for partners, then the community can write open source code that handles the translation and handles taking a lot of different documents and user profiles and so on, and allowing them to be merged and overlaid. And active participation isn't really needed from the people who actually control the data. So activity streams, activity streams is the standard, and Apache Streams is a project in the Apache incubator right now, Podlink Streams, if you will. And its goal is basically to unify this world of digital profiles and online activities into common vocabularies and formats, really just breaking down boundaries between data silos, because the data sets are more valuable when they're viewed together than when they're viewed apart. To make it easy and efficient for anyone to go collect data from a channel, you shouldn't need to spend an hour getting spun up in order to go collect some tweets or collect some photos. And then make those data sets accessible. So given that you've collected a whole bunch of JSON from the Spritzer, now what do you do with it? Activity Streams also has some bindings that can let you use that data directly in Cassandra or Hive or Pig without having to write all of the glue and schema that's required. So because we collect and define schemas for the data at the point of origin and in the normalized format, we can then turn those schemas into resources and source code that allow you to work with it more efficiently. And so the idea here is that data integration doesn't need to dominate the workday of a typical data analyst or data scientist. So what actually does Apache Streams contain right now? So I kind of describe it sometimes as a JVM reference implementation for activity streams and as an SDK for building data-centric applications. Some of this stuff is kind of hard to go through in a presentation, but it contains different modules for different networks like Twitter and Instagram and Google+ to let you bring data in, to convert it from its proprietary format into its normalized format, and then to run other sorts of transformation on it, and then to put it into different data repositories. It's pretty generic to mode of execution, so it does come with a local runtime that's suitable for multi-threaded micro-batch data processing. It's not nearly as good at that as, say, Flink mini cluster is, but it's a way to get data moving around. You can use basic console collation, think like run the main method of the provider and out the standard outcomes, all the tweets based on the search criteria that you put in. Can be embedded in a server where essentially You can run an endpoint, put your providers and processors in there, and then use REST bindings to have it do the work for you from the client perspective. But in order to really to see its true power, we run it in distributed pipelines, and Apache Flink is the primary engine that we use at People Pattern to run this code, and I'm going to talk about how we do that and why. So this is the People Pattern overall system architecture. I apologize that that's kind of hard to read, so no, that's not going to help. Essentially, we've got data coming in from a handful of different networks into a collection process run primarily by Flink, into a conversion process where we apply the conversions from the unnormalized form to the normalized form through a handful of different analysis pipelines that make those data sets more contextual, apply demographic and psychographic traits to them. A aggregation wherein we can look at all the posts that we're able to collect for a certain profile and then produce profile level characteristics based on the underlying content of the posts. An indexing step wherein we put different parts of the system into Neo4j, Cassandra, and Elasticsearch. All this is running in EC2. This is all running in Yarn. This is running in EC2 with Ansible controlling the databases. And then we have a handful of different APIs running on Dropwizard and Mesos that all support the application. So really all of this is in support of these APIs and this application. And that's what we've done. And I'm going to go now through each of these different boxes in a little more detail and talk about how they work. So starting with collection, here I've just depicted the Twitter and Instagram, but that's just for simplicity of the diagram. But essentially, in Twitter, they call them users and statuses, and in Instagram, they call them user info and media. But they really under the core share a lot of traits. So we'll have a job that comes through and can churn through IDs in a parallel pipeline and pull in the raw data along with essential metadata like ID and timestamp collected into HDFS and S3 in JSON form. So we do this for each of these networks to produce folders through the rolling file sync that contain all this data that we're pulling in day by day. Then essentially what we do is we invert the grouping, so wherein we start from a channel-oriented basis at a higher level, then we switch it over into a type-oriented basis and merge in all the different users, run them through a conversion step that's unique to that channel. And then what comes out is all the profiles across all the networks, all in a shape that we can analyze and index together, and ditto for the posts. Okay, so the analysis pipeline itself, it's a little better. The data starts off in S3. We run through these Spark jobs that are essentially map-only jobs containing machine learning models that we've trained using a variety of concepts. We can go into more of that a little bit later. So basically, every profile and every post comes through these jobs, and we make predictions about. I'll just pop to it really quick. So on the profile side, we are looking at things like the ID, the type, the name, the handle, and the summary of the profile, and spitting out predictions around account type. Is it a person, organization, birth year, when do we think they were born, gender, are they male or female, right? Stuff like that. And for posts, we're looking at the post and creating an array of what are the different interests that are expressed here. We have a universal taxonomy of 50 top-level interests, but we can also support bespoke interest definition using Lucene, where if you want to look for a really niche interest, the product supports you in doing that. What languages are used, and then is the sentiment positive or negative or neutral? So again, these jobs essentially just go straight through, but then they come out in Parquet format, which helps with the next couple steps. Right. So on the aggregation side, we've got these Parquet files partitioned full of posts. And essentially, we run an aggregate Hive job that goes through and takes all those parts and counts up the number of posts, the number of likes. It makes a map of how often are different devices used, different OSs used, what languages are they speaking, what interests are they posting or sharing about, is their general sentiment positive or not, and then what are the top hashtags and mentions that this profile is talking about. That's merged together with the Parquet file of profiles into a final index or Parquet index that we use to drive the indexing. And actually, there's a handful of different subfolders that the data comes out in. Then we are using Flink to actually write the data at high volume into our Elasticsearch index, our Neo4j index, and our Cassandra indexes. We're doing this over using the transport connector. Now that we have that, it's great. And then the Neo4j we write using the binary bolt protocol. And Cassandra, we're writing using the CQL binary protocol. So we end up building these databases of a handful of profiles, of course, of posts, of connections that we collect about who follows who. And then we organize some of the data a little differently in Neo4j, because a lot of our queries will kind of do a lookup to Neo4j to find out what it is that we want to look for based on the connections or labels on the accounts, and then actually go off to Elastic to pull it and aggregate it all together. So this is just a pictorial of the actual access patterns and how the app uses them. There's two main APIs. There's an access API where we're allowing our app or partner apps to do a straight lookup based on IDs. So up to 50,000 IDs, you can immediately go and pull predictions and in aggregated values off those profiles. You can pass in up to 50,000 IDs and have the API count up what is the percentage usage of this language, this device, this operating system. What are the top hashtags across all of the posts across all these accounts. And then we support a search-based endpoint where if you know that you're looking for females who are Hispanic, who live in Southern California, who like baseball, right? You can construct that as a search, and the API will come back and tell you, well, we found 40,000 of them, and then you can use that information to inside the app to do a number of things, which we'll go through in a minute. From the entity side, we allow basically you can take a profile and put a label on it. You can take multiple profiles and organize them under what we call a portrait, which is an identity that contains multiple profiles. And then we also expose via API all of the friend and follower connections that we get from Twitter as we collect data, go through that as well, and what we can do with that, which I think is pretty cool. So all of this stuff is pretty much happening in the background. It's not user directed for the most part. But we also have a reporting framework that is more user-directed. And this is essentially a user says, I'm interested in this specific segment. Go collect and give me more detail about this segment. We'll talk about what some of those different reports are and how they work. But in this case, where we'll actually go launch a Flink job or a Spark job on demand to run on Yarn, to go do a computation, do a little bit of collection if necessary, and then save out the output in a JSON object that can then be turned into a PDF or browsed directly in the app. So now I'm going to just kind of walk through some screenshots, and I might even just pull up the app if I can. I think I probably can. Give me a second. Cool. So this is the people pattern application. So I created a project of, I'll tell you what it is. This is just kind of to show off some of what it can do. But all the Twitter followers of @Apache Flink, Twitter keyword search that uses the different hashtags for the conference. And this ran a couple days ago, so it probably doesn't have everything in it. And then also just a generic portrait search looking for people who in their bios state the word software, data, and who our algorithm has determined is a person as opposed to an organization. And so this is the portrait data set that produced, 6.25 thousand individuals. Probably some of you in this room would have been picked up if you've been tweeting or follow Apache Flink. A whole bunch of posts about that, about Flink and then about other things in general. The app puts them into different personas based on some of the language they use. So early adopters, networkers, and driven professionals are the top 3 personas in this project. There's also some clustering that goes on wherein we look at the different interests that are being mentioned. Say, like, there's actually a persona here that seems to be an intersection of computers, business, science, consumer electronics, and reading, while there's another persona that's about, that talks more about movies, politics, and business and travel. These are kind of the roll-ups or the top sections of each of these different categories. Computers is the top interest by far, but business is hanging in there too. And then these are the locations primarily where these people are living. Some of the top accounts that are mentioned, and then within the group, like some of the top influencers of each of these different categories. So we also have a way to describe essentially bespoke portraits, which we call brands. So I created brands for Apache Spark, Apache Flink, and Apache Hadoop, and this allows you to do kind of side-by-side comparisons on within this population set. How often are these different things mentioned, and is the sentiment generally positive, negative, or neutral? You might imagine that marketers really geek out over this stuff. So, the audience that you get is only as good as what queries you use to produce it. But this sort of thing does happen. So in that case, we allow the agency or the brand manager who's doing the analysis to go in and quarantine portraits and say, for whatever reason, this got in. We don't want it to show up in our presentation to our customer. It's essentially hidden for all intents and purposes. Okay, so this is the kind of the first page that you can see. We have this audience. This allows you to really get in deep. Can do additional searches on the bios and on the post content. Where there's a color difference over here, and these colors this is where we actually have done a geolocation pin. So one of the steps in our analysis process looks at the stated location and does a lookup against a copy of geonames that we've indexed and tries to determine the most likely actual real city with a lat long with a neighborhood as part of the geotaxonomy that they're talking about. And so these colors are where we've got a real match, whereas East Riding of Yorkshire, this didn't quite give us a high enough confidence to state that it was a specific place. You can sort these, and it's pretty common. Sort these by the influence score. I guess Penn Jillette is a follower of Apache Flink, or is talking about it, or is talking about that other film festival, one or the other. We can, what's the best way to do that? Look at posts as well. Facet down to within the groups that we brought them in. So if we just want to look at the matches that we did from the portrait database, we can filter down to just that group. We can look at just specific social platforms. So we're going to look at Twitter only. Only people who use Android. Only negative sentiment, right? So this faceted navigation lets a marketer drill in pretty closely to look at the conversation around their brand, or at the portrait level analysis is really the main point. We have other analysis features. I'll show you this one. This is if you're specifically interested in analyzing interests. And this is a React app that's written to be highly responsive. So you can kind of toggle on different interest groupings. And all these pieces kind of update live. So what are the top hashtags being used within this specific group? And as well, the percentages in some places will shift as you narrow in on a smaller segment. Again, here you can sort by influence, and then we can drill in again on a specific interest category. In addition to computers, which is selected as a top interest. More kind of comparison features. And then we have the reporting framework. So this is what we call the external influencers report. So essentially what we have done here is collected this audience, and now we're looking at all of the accounts that they're following, and comparing it back to a normative set of what across our benchmark audience on Twitter, what accounts are followed. And what winds up happening is that accounts that are disproportionately followed by this audience rather than by an average Twitter user bubble up to the top, and that's reflected in this delta. So 0.3% of our benchmark group follows GitHub, but 28% of the Flink followers and mentioners do. And this is all reverse sorted and goes on for pages and pages and pages, 140 pages. And then we also are looking at these and bucketing them up into categories. You can look at across the education category. These are the top most followed accounts by this group. And the same for all these other categories. This is called, I guess, influencer analysis. So a lot of times a brand will want to partner with some other organization or individual to get the message out about a campaign they're running or a product or an event. And this kind of lets them know, based on the group they're trying to reach, who are the right individuals to target or organizations to target. You can also take these as inputs to what I'll show you now, which is activation. And this is essentially a direct hookup into the Twitter advertising API. And so the segments that you've built throughout the app can be used to target messaging, product promotion, site promotion, and other sorts of campaigns off of Twitter. So you can basically find out who the top influencers are, build a segment of that, and then directly target followers of those accounts, for example. That would be a kind of a common thing. Okay, I'm going to go back to the presentation, which I think is more or less at the end, and then I would love to answer whatever questions you have about this. I didn't maybe show any Flink code. If you want to talk about the Flink code, I'm happy to talk about that too and how it works and what it does. But in conclusion, Flink is the system that allows us to ingest 60 million tweets a day, 10 million Twitter profiles a day, and to run all these analytics on it rapidly and keep our database growing and up to date. Our database is currently over 300 million profiles, and we've really focused just on a handful of networks. So we're continuing to try to grow the database and continue to improve our analytics and our ability to service customers. Thanks.
Pretty impressive, thank you. So it looks like, Twitter is a lot more prominent than perhaps LinkedIn. I suppose that's because Twitter makes it so easy to get to the data, and it's just a question of money, and you get the whole stream, I suppose. But I'm a little bit more interested in LinkedIn. I mean, many of us here, many of the presenters have said we are hiring, and so there's definitely a hiring use case, right? I mean, I would love to be able to send an email to those, 128 LinkedIn profiles that are interested in Flink, because I would like to hire them, for example, right? But LinkedIn is actually very ungenerous with their data, right? Can you talk about your experiences there and perhaps some of the thinking Why?
So that's right. There's very little that you can get from Twitter's API publicly, and so that impacts what we're able to do with it. LinkedIn and Facebook are two examples of where they've built a massive company around collection and efficient usage of personal data, and they understand that their primary value add with that asset is to be the place, the one-stop shop to actually get additional insights and get activation. So whereas Twitter has a API that allows anyone to plug in and run ads, everyone kind of has their own stance on how much data they want to share and under what circumstances. And LinkedIn is at one end of the spectrum and Twitter's at the other end.
I really mislike LinkedIn for that aspect because I pay a premium service for my own LinkedIn account, and I cannot even download the details of my own contacts. I find that quite disturbing. I only get like name and email address and some other attribute, but this is my data. I would like to, to have my own data at least in spreadsheet or whatever.
Yeah, so continuing on that, it's my data. Who owns the data at your platform? Because you scrape it from Twitter and Facebook and other parties, but basically that's an important question right there. Because you also had these chain letters saying that all these people post like, yeah, Facebook cannot use my data because of this and this. So how would you look at that? Because actually in Europe, in 2018, there is going to be quite some strict laws also about, who is the owner of the data and the right to be forgotten and all those things. So what's your vision on that?
So this is publicly available data obtained legally. You can opt out. You can let us know you don't want us to keep your data, and we'll get rid of it. Longer term, I think this is one of those questions that we're going to be talking about a lot more in the coming decade. And right now, different jurisdictions are taking different stances on it that are not likely to be very compatible and might restrict the ability of businesses to work across jurisdictions. And so as a data professional, I find that unfortunate, but I also think it's very early, and public sentiment can change in response to events or to leadership, or just to the old guard kind of like retiring and getting quieter while the younger generation comes up and has different ideas about how things ought to be.
A more technical question, maybe. I've seen your slides that you use both Spark and Flink. Could you elaborate a little bit why you use both of them? Because in my understanding, they're quite similar and more competitors, maybe even. So you might have a reason to use both of them.
So I'm using both for maybe some historic reasons. Started using Spark a couple years ago around, at People Pattern, we started using Spark in version 1.2. So Flink was maybe not as far along at the time, and so we built a lot of the stuff around it. And it's quite nice with Yarn to be able to run workloads of either sort. With the data stored in JSON, at least in S3, you can go back and forth very easily. Typically, I definitely prefer Flink for anything that has real-time throughput needs, or a lot of transparency. So the stuff where we're running Spark is batch workloads only, and in general, not all that complicated, like a handful of transforms, a handful of joins, and a couple filters. Probably any of it could be ported to Flink with the right reason to do so. Maybe one of the areas where I think maybe Spark is still ahead is using data frames with different backing stores, but being able to look at them commonly just as data frames, and then allow some of the filtering and aggregations to get pushed down into the databases. So there's certain sorts of analysis where, for example, we want to take some data that's in Cassandra and some data that's in Elasticsearch and run a calculation on them without having to pull them all out into memory first, where data frames are nice. But yeah, in general, most of the batch computation we're doing in Spark could be done in Flink also, and it would probably be about the same number of lines of code. Question back there?
Do you have some examples in Flink? You don't have to show them right now, but are they posted and available if we wanted to pick up and use Apache streams in Flink?
I will put some in this presentation in the next couple days. This is all hosted on the web, so I can change it pretty easily. And I imagine they'll be sending around links to everybody. So I'll try to get those in there before the PDF goes out with all the slides.
That would be excellent.
The answer is yes, essentially, for both these, for the collection of the data and the normalization and indexing, it's essentially rich flat map function with open, basically pulling in a serializable configuration, creating whatever non-serializable stuff it needs to talk to databases or to convert the data. And then it's essentially chugging through all the data in a partition, and then you close it out when it's done, and it releases its connections. But it's pretty simple to embed data collection or data transformation stuff into Flink or into Spark for that matter.
Awesome.
All right, well, thank you for listening.
Yeah, thank you.